Let's see what's going on here in 17. We've got an urn. Let's draw our urn. As soon as they see that, I'm going to draw that urn. So this urn contains 5 red, 3 yellow. Right, so let's summarize. N is equal to 8. And then what we're going to do is this. We're going to select the marble, notice color, and then not place it back. Right, so we're going to take a marble, take it out. Then we'll choose a second marble. What's the probability that both are the same color? So let's think about how can this happen? How can we get both of them to be the same color? Well, we could get this, right? We could get, this is a probability that we get what? A red on the first and a red on the second, or a yellow on the first and a yellow on the second. Let's draw a tree diagram. This is one of those sequential problems, so tree diagrams seem to work well for this. So we'll have a first draw and a second draw. Well, first draw here. So what we want, what could happen on the first draw? We could get a red on the first, or we could get a yellow on the first. Then we'll take a second draw, and we could get a red on the second, not that one, or we could get a yellow on the second. And down here, if we got a yellow on the first, what could happen on the second draw? Well, we could get a red on the second, or a yellow on the second. Now let's get these probabilities. So right here, what's the probability of getting a red on the first? So go back up here. We've got 5 reds in a box of 8. So this probability is going to be 5/8. And then the probability down here of a yellow on the first, there's 3 yellows out of 8. So this is going to be 3 out of 8. And then for the second draw, what's the probability here of getting a red on the second? Well, we took a ball out, right? We took one of these marbles out, so there's only 7 left, and we got a red on the first. So there's 7 left, and we took out a red, so there's only 4 reds left. So this is going to be 4 out of 7. And here, a yellow on the second. Well, we haven't removed the yellow, right? We got a red on the first, and we tossed it out. So there's 7 left, and 3 of those 7 are yellow. So this is going to be 3 7s. And of course, you know, these add up to 1, right? And then down here, if we got a yellow on the first, what's the probability of getting a red on the second? Well, we got a yellow on the first and we tossed it out. So there's 7 left and all of them are red. So this is going to be 7, not 7. How many are red? Let's get rid of that. There's 5 reds and only 7 marbles. And now we did get, let's go down here. What's the probability of getting a yellow on the second? Well, we got a yellow on the first, we tossed it out. So there's 7 marbles left. We had 3 yellows, but we tossed that out. So there's only 2 yellows left. So this is going to be 2 out of 7. And again, of course, these add up to 1. So to get here, a red on the first and a red on the second, we're following this branch and this branch. So this is going to be 5/8 times 4 7s. So we're going to get 5/8 times 4 7s, or, now there's a plus, we could be down this branch here, yellow on the first and the yellow on the second. So down that branch, that's going to be down that 3/8 and then the 2 7s. So what we're going to do now is we're going to add, make that addition. And when I made that addition and multiplication and addition, I ended up with this. I ended up with 0.4643. So if we round it off here, that's saying this event, getting both the same color, would happen about 46% of the time. Number 18, we've got this drug testing problem. So suppose the drug test is 99% sensitive and 94% specific. Now here's what that means. These are just some terminology here. Here's what it means. If 99% sensitive means the test will produce a true positive result for drug users 99% of the time. So it's the 99% sensitive means that if you're really a drug user, the test will detect it, that you're using the drug 99% of the time. So that'll give a true positive. And then it'll give 94% true negative. So if you're really not using the drug, 94% of the time, it will say, no, you're not using the drug. So suppose we know this. Suppose that 0.8% of people in some group use the drug. Now, somehow you just know this number. That's debatable whether we would ever know that. But let's just suppose we do. So if a randomly selected individual tests positive, so you go in, you take a test, and you get a positive result, what's the probability that he's a drug user, that he uses that drug? What we're looking for here is this. What is the probability of using the drug given that you got a positive result? That's what we're looking at. Well, this is a conditional probability, right? What is the probability that this event occurs on the condition that this event occurs? And we have a formula for this, and the formula goes like this. It's a fraction, and in the top, we take the probability of the intersection of those two. So this is going to be D and plus, and in the denominator, we put the probability of what's given. So in the denominator, we put the probability of what's given. We're going to get each of these probabilities from a tree diagram. And that's how I usually like to do these conditional probabilities. I'll write the formula, and then I'll go to a tree that will lead me right to these probabilities right here. Now, we can get these probabilities from a tree diagram. So what I'm going to do is right here, I'm going to draw a tree diagram that moves out with branches moving out to the right. So let's start here. And what can happen is, look at the sequence of events here. We have using the drug and then getting a positive result. So probably what comes first is using the drug or not using the drug, and then, right, using or not using, and then you go in and get a test. So the way I'm going to start this is to write this as this branch here and this branch here. This will be using the drug. This will be not using the drug. Now, what is this probability here? We're given up here that the probability is 0.008 of using the drug. So somehow somebody knows that 0.8%, 0.008 of people use this drug. So we're going to have this as 0.008, and then 1 minus 0.008 is 0.992. Now, up here on this first branch, this is people who use the drug. Now, they go in and get a test. It can come out either positive or negative. So from here, we'll go here. So we could get a positive result, or we could get a negative result. Now, the probability of getting a positive result, given that the person uses this drug, that's given up here, where it's 99% sensitive. That says that the test will produce 99% of the time true results for the drug users. So if you're using the drug, you'll get a positive result 99% of the time. So this probability here is 0.99, and so this one must be 0.01. So what this says is that if you use the drug, you'll get a false negative. That means you're not using it, but the test will come back negative. And then likewise, down here, if you're not using the drug, you go get the test, and let's see, what could happen? You could get a positive result, right? That would be a false positive. You're not using it, but the test says you are. And then you could get a negative, which would be a true negative. You're not using it, and the test says that you're not. So what's this probability? Well, what's this probability right here? If you're not using the drug, you get a negative result. That's given up here. 94% true results for non-users. So you'll get a true negative if you're a not user. You get a negative if you're a not user, and that will happen 94% of the time. So this is 0.94, and so this must be 0.06, and that is a false positive, right? Because it says you're using it when you're not. And now we have enough information to get our probability. So look at the numerator up here. The numerator is D and plus. Now D and plus, that's this branch right here, right? You start out with D and you go to plus, so that's going to be 0.008 times 0.99. So I'm going to do this down here. So we're going to write this big fraction bar here. And on the top, I'm going to put 0.008 times 0.99. Now the denominator is getting a plus. So how do you get a plus? Well, there's two ways to get a plus. You could get a plus on this branch right here. You can get a plus on this branch right here. So there's a couple ways to get a plus. So this one right here and this one right here. So let's get those numbers. Now one of these denominators will always match the numerator. So that's going to be this top one right here. So how do you get a plus? It could be this one here, or this one down here. So let's write those probabilities down here in the denominator. So this one up here, that's the 008 times 0.99. So this one is going to be 0.008 times 0.99, or plus this one down here. How do you get to this plus? This branch here, 0.992, 0.06. So this is 0.992 times 0.06,